Hello everybody, Mr. Rubo here. Today we are continuing with 1.9, 1.10 rational functions, vertical asymptotes, and holes. And today we're actually going to talk a little bit about what we talked about last video, but just kind of a little bit more in depth and seeing a couple examples, different examples here. So if we have a hole, remember that is when we have a factor in the numerator and denominator that is the same. Right? And so when we can reduce it, we do that. And so if we reduce f of x, we're going to assume r of x is the reduced function. Okay, so they're representing the same function. F of x would have the whole, r of x no longer has the whole. Okay, and so if you want to find what the limit is as x approaches whatever that a value is, that x value that the whole is, from the left side and from the right side, it's going to be equal, and it's going to equal whatever you would get when you substitute in this a value, this whatever the x value is, into the reduced function. Okay, so you substitute a into the reduced equation. Okay, that's how we find that limit. Okay, as far as vertical asymptotes go, though, this is where we are going to talk about infinities, okay? And when they can be the same, when they can't be, okay? So the limit as x approaches a from the right of f of x, what you want to do is substitute a value slightly greater than a. So if you think the vertical asymptote's at 1, substitute in like 0.01, right? And you'll see it'll either be something really, really large, like close to, going towards positive infinity, or it could be something very negative, so going towards negative infinity. If you're looking for the limit as x approaches a from the left, then we're going to substitute a slightly less value than a. Again, if it's 1, put in 0.99. Okay. Now, the nice thing is if you pay attention to the multiplicity of those factors, of the factors of the vertical asymptotes. So if the multiplicity is even, and as in case you forgot, multiplicity again is the degree of the factor. Okay, so if you have x minus 1 and it's squared, it has an even multiplicity because it's squared. Okay, what this means is that both from the right side and from the left side, they're the same. So from your vertical asymptote, it's either going to go like this, where they're both pointing up, or they're both pointing down. That's an even multiplicity vertical asymptote. If the multiplicity is odd, then they're going to be opposites. So one's going to be positive infinity, one's going to be the negative infinity. And just like the even one, there are two possibilities. You could have the left side be going up, or, whoops, that should be dashed. Or you can have the right side going towards positive infinity. Okay, so there are your kind of two options with multiplicities. It makes our lives easier where we don't have to substitute always in. If you know what one side is and the multiplicity, you then can just know like, oh, it's going to be up and up, or it's going to be opposites. Okay, and I did mention this last video, but again, it's always good to note a vertical asymptote will always trump a hole. So if you have a vertical asymptote and a hole possible, graphically it's a vertical asymptote. Okay, and then a hole will trump an x-intercept. Okay, so if you had x minus 1 squared over x minus 1, the x minus 1s cancel, but even though you have x minus 1 in the numerator, that would tell you have an x-intercept, because you had a hole initially, the hole trumps it. Okay, so just keep that in mind if that ever comes up.